Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at NVIDIA NIM. It's a new innovation by NVIDIA, and NVIDIA has been doing a lot of innovations lately. You would probably heard of NVIDIA's new chip Blackwell. Jensen Huang has announced that in GTC 2024. But not only that, they have other innovations that will probably help accelerate your Gen AI based development workflow. And we're going to look at NVIDIA NIM, which is really a remarkable piece of innovation that NVIDIA has done it for. And it's just to tell you what NVIDIA NIM is, or NVIDIA Nim is. It's an inference microservice that has been designed for enterprise grade LLM or Gen AI deployments. I will say like that. Okay, so it's an inference microservice that they have designed and they have built it, and they support almost everything, the open source LLMs, the closed source LLMs, even if it's an NVIDIA based or without NVIDIA based, like it's not available or within an NVIDIA server or a marketplace, or even if it's not backed by a Triton server. So we'll talk about that. We'll see that in a bit. But the agenda of this video is that we'll quickly look at NVIDIA NIM, that why should we use this amazing cloud native. When I say cloud native, focus on this, right? Because this is very important in an enterprise. It's a cloud native inference microservice, and that's really amazing. And we'll see how we can use this to probably build a RAG kind of a pipeline and see how we can leverage that. And the good thing is it's available stand alone. You can use it in Python. You don't need an orchestration. You can just use as it is, and you can also use it through LangChain. So there is an integration with LangChain as well. Without wasting our time, let's jump in and see what we mean by NVIDIA NIM or NVIDIA NIM and how that can help us build solutions faster and with ease. Now, if you look at here on my screen, I am on NVIDIA build dashboard. Okay, NVIDIA Enterprise AI, and I'm on the dashboard where this is a great dashboard. Probably if you are not aware of it, you should spend some time. Most of the enterprises, when I talk about the orgs like Deloitte, for example, or any other, right, the bigger organizations, they have partnership with NVIDIA, and they work with NVIDIA, on different things like their cloud platforms, their products, services, and things like that. So in a lot of enterprises, they use NVIDIA products. And if you are one of them, probably you should now shift to NVIDIA Nim, and we'll show you how you can do that. Now, here I am on dashboard. 1000 credits for free. You just have to log in on build.nvidia.com. Go on Google, any web browser that you use, build.nvidia.com, log in with your Gmail, create a new account, and then this is what you will see. If you see on the left hand side, they have the models. In models, they have categories like reasoning, mainly text-based LLMs in the reasoning, where you have Mistral, and we're gonna use Mistral today, to build a RAG kind of a pipeline using HyDE, hypothetical embedding. So we'll talk about that. Very interesting. Now, Mistral at X7B instruct. We have Llama 2, the Gemma by Google recently last month was announced, and other models. In visual design, you have models like Edify Image, which is by Getty Images. Then in retrieval, you will see a lot of retrieve, like an embedding kind of a model where you can do that. Okay. And then in speech, we have, you can see Parakit here. In biology, we have ESM4, a protein. It's basically predicts the 3D structure of a protein, and that's what it does. And we're going to focus on Mixtral. So when you click on Mixtral, it will take you here, where like a playground, and you can also apply to self-host. So you can self-host it as well on the same platform. And then you have a model card, you have how to, call this, and blah, blah, blah. This is not our focus, by the way. Okay, our focus is on NVIDIA Nim. Okay, let me show that. Okay, now let me just close this here, by the way. We'll see how we can use this in Google Colab. Here you can see, let me just install this. I'm using Colab and I'm installing it over here. And you can see I have installed LangChain NVIDIA AI endpoints. And then I also need LangChain community, LangChain text splitter, and fast as a vector store to do that locally. I'll restart session. So let me just restart that. Okay, I'm restarting it, and it says keyword interrupt. So the good thing about it is to take this in the next line. Okay, and then I'll just put it over here. And to use that, you will need an API as of now. So what you have to do, you have to do get API key over here. So you can see get API key, and you can also do that. Okay. Now let me show you that why you should use this. Because it also supports open source. Now, if you look at here, I'll give this code, the code and the instructions in the description of this video. You can go through it. Let's read that. You probably do not have to rely on the closed source like you have been using through NVIDIA APIs, and you don't have to do that. You can also self-host it. You can self-host the LLMs using NVIDIA NIM. I'll show you how. Now, if you look at here, it's first you have to do it, download the model. So you're gonna use the NGC registry where they have probably a container registry where they have all the hosted Docker images of the LLMs. You have to go there, you have to download the model. So in case of Llama 2, you can see this is how you download using this command in NGC registry, and then you unpack that wherever. So if you are using a local machine or a virtual machine on cloud or wherever, this is the command that you have to run. You need Docker install, of course, in that. And this is how you can unpack that, and you can see this is how you're unpacking it the model image is, look at the model image, llama 2 7b 4K FE16, so floating point 16 half precision, and then A100 one A100 it requires to run that. Okay, now we are running a Docker, launch the NIM container. You can see this is how easy it is. Download the model, unpack, use the Docker to run it. You can see launch the NIM container with your desired model. Okay, so you can just run it with any model that you want to run it, that NVIDIA of course supports. And once that is deployed, you can just start making calls using request module. Yeah, simple as that. If you don't want to use LangChain, because it's prone to SQL injection, slow in productions, have a lot of bugs and blah blah blah, right? So you can just use it as a request module. You can build your own pipeline for RAG and things like that. So you can do it open source as well. Probably you do not need to use it as an NVIDIA API endpoint, but just to keep it simple in this video, let's see how we can do that through APIs over here now. Okay, now let me just install this. Now take a bit of time. So what you have to do, you have to get an API key. So you have to come here and just click on get API key. So I'm not clicking because I already have that. Okay. So you can see this is where I have in my environment secrets on Google Colab, I have my keys by NVIDIA underscore API underscore key, and then I have stored my keys over here. So once we are done with that, let's get going, guys. So what I'm gonna do is I'm gonna get few things from LangChain underscore NVIDIA AI endpoints. I don't need that. Okay, I need two things from NVIDIA AI endpoints integration in LangChain that we have. I need two things. One is the NVIDIA embeddings. Yeah, NVIDIA embedding, that is right. And then I need chat NVIDIA. I need chat NVIDIA, that is right. This is what I need. So you can see this is done. We have successfully imported this. Now the next thing that we're gonna do is we're gonna get our web-based loader, because I'll show what is going to be our source document. We're gonna build a RAG pipeline here. So from LangChain underscore community, and then I'm gonna have document loaders import, not PyPDF. Let's get the web-based. We're gonna take a documentation of Langsmith. And now let's get our loader up and running. So loader equals, and I'm gonna pass web-based loader. Not this guy. Okay, so to you can see I have Langsmith docs. So Langsmith is a platform for LLM application development, monitoring, testing, helps with evals, helps with the prompt logs and things like that. Has been created by great Harrison Chase team, at LangChain. Now what I'm gonna do is I'm gonna copy this over here. Okay, so let me just copy. You can take any other URL as well, and I'm just gonna run this loader, and then we just do docs equals loader.load. This is how I'm gonna load that, and this is how you get the docs thingy. Now once you have docs, we're gonna bring up our API key in this, which is in the secrets. We'll keep this in an environment, so let's do that. So for that, from Google dot, you can see this is what it's showing. Let me just, yeah, I'm fine, I can just type it down. Okay, from google.colab import user data, and then I need import OS. Let's get these two things. Now next is os.env. Okay, the environment. Okay, so os.env, and I'm gonna pass my NVIDIA underscore API underscore key, and then here I'm going to write user data dot get user data dot get, and then I'm going to pass my NVIDIA API key. I'm going to grant the access. The moment you grant access, these guys will get blue enabled, like it's enabled. Now you can access that thingy, here in the notebook. Now, once we are, I think we are done with that, guys. So now what we're gonna do next is let's get the embedding model up and running. So embeddings equal, let's call the embeddings here, NVIDIA embeddings class, and I'm getting the embeddings, and I probably need a couple of other imports. So from langchain dot, not dot, underscore community, from langchain underscore community underscore vector store, this is fine. And I'm gonna have import fast, this is right. And then we also need what? From langchain, we need a text splitter, guys. So text splitters, import, let's get recursive character text splitter, and then I'm just going to run it. Okay, and I think we are done with that. So we are done with our imports. So let's quickly create the vectors. So text splitter, chunk size 1000, too much of chunk size. Let's keep it a bit smaller. Okay, so I'm going to make this as 500. And then I'm going to make this as probably 50. You should always keep 1/10. That's how they recommend it. When I say always, I'll take the statement back. Most of the time, you should keep 1/10 of your chunk size as an overlap. So let's just keep on running. Now we have our splitter here, text splitter. Splitted it, using on the character recursive character level. Okay. The next is documents. So documents equal, and I'm going to pass my text splitter dot split documents, passing the docs, which is right. Docs is here, and then if you look at documents, let's have a look at documents. You can see this is the documents of there's basically a list. So I'm iterating through the list, getting the first item out of it. So document 0. And you can see this is the page content. This is how the default structure of page content that you see it over here, and a metadata. That's what it is. Okay. Now document 0 is done. So what I'm going to do next is creating a vector. So vector equal fires dot from documents, passing the documents and embedding. So let's do that. So I'm passing the documents and embeddings on this vector thingy, and we are done with vector. So let's create a retriever variable. You can also persist it, guys. If you want to save that, you can do vector.save local, and you can just persist in a directory. I'm not doing it. Probably I have created more than 50 videos on RAG. Go to my RAG playlist and you watch n number of videos. I'm not repeating the same thing. So retriever vector.add retriever, and let's just run it. And then the retriever is done. So far we have done the retriever part. Now we'll go into the generation part. And for this, we're going to use few things, guys. We're going to use HyDE, hypothetical embeddings. No rocket science. One of the way of building RAG, there are n number of ways of building RAG. The merge retriever, which is also called LOTR, Lord of the retriever, hypothetical embeddings, ensemble retriever, multi-query retriever, blah, blah, blah. And you do not have to probably go anywhere. You have to go to LangChain documentation. I will show you how easy it is. Okay. Now, what I'm going to do here is I'm going to use LangChain, the new version of writing chains. I'm not going to use the legacy version of writing chains like retrieval QA dot from chains and then giving. I'm going to use the LCEL, LangChain expression language. I have a detailed video on LangChain expression language. I'll give the link in description. Please go through it. Now here from LangChain dot, not dot, core dot prompts. We need a prompt thingy. So core dot prompts import chat prompt template, and then from langchain dot core dot output dot parsers, I'm going to have import, and because we're going to parse the output, so let's get that string output parser. We are done. We have our this thingy done. Now let's create let's get our model, guys. So we're going to use Mistral here. So let me just do that. So what I'm going to do is model, okay, excuse me, model equals, and you can do that in free, 1000 credits they give it in free, so you can do that. Now here chat NVIDIA, ah chat NVIDIA, let me just come over here, and inside this I'm gonna pass, excuse me, what's happening, okay, chat, I'm gonna pass my, okay, all caps on, I'm gonna pass the model name. So this model is, and you can see that here, this is the model that we're gonna use. So we're gonna use the Mistral 7B. Let's use Mistral 7B for this. Okay, but you can also use Mistral 8X 7B, but I'm going to use Mistral 7B. So I'm using the Mistral 7B, but you can use a mixture of expert model as well. The focus here is on the NVIDIA Nim, guys, the NIM, not on using any LLM. You can use any LLM as you want. Okay, let's get the model in. So we have the model, and if you print the model, probably I'm not going to print it because it also prints you the API keys. Now we're going to use HyDE. Okay, and I will show you. Okay, what HyDE mean is, guys, it's simple, hypothetical embedding. So just try to understand from the word only, hypothetical embeddings. So basically, when you fire a query to a system that you have built, a LLM powered system or a RAG pipeline, when you hit a query, fire a query. So what it does, if you read also here, it says enhance retrieval by generating a hypothetical document. So once you are passing a questions like, give me five top insurance policies, for XYZ company, and you have some context in a vector database, what it will do, it will first take you a query, and then it will generate a hypothetical document for that question that you have asked. A document will get created, and then this document is embedded. The document is embedded separately, and that your base vectors are already there in a vector database or a vector store for your document that you already have in a database or a source database or knowledge base, whatever you have. The question that you ask for that particular question, a document gets created, and an embedding gets created for that document, and then the embeddings get matches. That's how interesting it is. If we look at here, then that embedding is utilized to look up real documents that are similar to the hypothetical document, which is fantastic. And why this is important? Because OpenAI, in their development days, OpenAI dev days, just before Sam Altman firing, 2 days back of Sam Altman firing, OpenAI was showing their RAG journey. Let me show you that quickly. Okay, and that's why, guys, you have to watch the complete video, because in this between the video, I kind of keep sharing this information that is helpful for you people. Okay, so OpenAI RAG pipeline or RAG, OpenAI RAG journey, dev days or something. Let me find it out, that image. Here it is. You can see this is how they improve. So this is RAG, their journey, OpenAI journey. And if I make this a bit bigger, so you can see this, you can read it over here. They have something called HyDE retrieval. So they tried, so they tried with HyDE, they tried with a full fine tuning embeddings. They would probably fine tuning also chunk embedding experiment. So they have tried all of this. So they started from 45% to 98% of the RAG journey that they have. This is fantastic. They have tried their own, when then the chat GPT, you can upload file and you can chat with it, blah, blah, blah. They have used all of this, what you were seeing. Probably they would not have been using HyDE. They would have, of course, far more advanced than what HyDE can do. Now, so we're going to focus on HyDE here. And let me show you how you can do that. So for HyDE, you're going to have an HyDE template. So let me just create a prompt template here for HyDE. So in HyDE, this is how you do it. So HyDE, let's give a doc string. And I'm going to write, even if you do not know or do not know the full answer, generate a one paragraph hypothetical answer to the below question, and then you can just give the question, and I don't need the answer. Okay, so then you can just give the question here. Okay, and I'll just pass the question. We don't need this as a label, and the question is done. This is what we're gonna do it here, guys. Okay, now we have an HyDE template. Okay, now once you have and I'll just get rid of this as of now. Okay, so HyDE template, this HyDE is done, and then I'm gonna create a HyDE prompt. So we need a prompt. So HyDE prompt equals, and then once we have the HyDE prompt, chat prompt template from template, chat prompt template from HyDE template. This is fine, and this will create an HyDE. I mean, this will create a prompt object. If you want to know that, then just get it over here. You can see here, right? This is what it is. You can just see that. And now let's get a chain. So I'm gonna do from excuse me, from LangChain core dot runnables import chain, and we are good with this. HyDE prompt. I'm missing something. I'm missing the HyDE retriever. So once you have the HyDE prompt, we need a HyDE retriever. So let me just write that HyDE retriever, and HyDE retriever. I'm gonna pass my HyDE prompt, and then I'm gonna pass. You have to write use pipe. So HyDE prompt pipe, and then I'm gonna pass my model, and then again pipe, and then I'm gonna pass my str output parser. That's what I'm gonna pass here, guys. Okay, HyDE prompt, model, and str output parser. And let me just add HyDE retriever, print HyDE retriever here, so you can just have a look at that. This is what it is, and you can see it completely over here. Okay, API key is secret anyway because we have one from ENV. This is how the entire pipelines or the chains looks like. Now we have the chain over here. Now let's create a decorator. So we're gonna have a chain, and in the chain we're gonna write a function called HyDE underscore uh, HyDE rate. Let's call it HyDE rate, and in HyDE rate I'm gonna pass my question. And inside this function, HyDE rate function, what I'm gonna do is I'm gonna write hypothetical document. Is getting caps. Hypothetical document equals HyDE underscore retriever, and then passing not question. You can have to use the invoke function. They have an invoke function. So let's get the invoke function. This is right. Question, and then return the hypothetical, or we can just return again. You can invoke it, right? So hypothetical HyDE retriever hypothetical. We should not return this. What is our retrieve? Okay, we should return the retriever. So retriever dot invoke, and then we should pass here in this our hypothetical document. This is what we should return. This is making sense now. Okay, so now we have the HyDE. Now we need a template to generate the answer. So that template is fine. So let's just get a doc string again with one line of code quickly. You can make it even better, right? So answer, just simple rag prompt. Answer the question based on question based only on the following context, and then we're gonna just pass the question, passing the question, not required. Our template is done, guys. And let's again create a prompt for this, because HyDE prompt was different, this generation prompt is different. And I'm going to pass chat template from template, passing the template. This is cool. And then we need our answer chain. So HyDE chain was on top, now the answer chain. And in answer chain, what we're going to do, again we start with prompt and passing the model again. Just give me a minute. HyDE prompt. Okay, I was just saying that if I have used the same thing, HyDE model, and then again the string output parser. And this is the answer chain. And now let's run that. Okay, so what I'm going to do is again a chain, write a function to get the output. So final underscore array, this is getting caps always because I do that question, final chain question, and then documents equals, I'm going to use hide rate, of course, and dot invoke, passing questions, and then I'm going to have a return. Let's do not return like this. This is not what I need. Okay, I need a, let's keep a for loop. So for I'm gonna do is for s in answer underscore chain, and I'm gonna get a streaming response. So let's get a stream, and again a key value pair. So question, and then goes inside question, and then passing context, and then passing the documents, and then just yield. Let's yield it. Yield as okay. Let me just think of it. So document HyDE rate blah 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 invoke question for as in answer chain dot stream question context document. I think this makes sense. Documents question invoke. Let's run it, and then I'm gonna have for s in final chain dot stream. Okay, it should show me now. I don't know why it's not showing me. This is what happens when we have to use divine, I feel, guys, divine, whatever. Okay, so that agent needs to be here in this Colab. Okay, stream. How can Langsmith help with testing? And then just print, and you can use stop as well. So I mean, not stop, end. You can use end wherever there is a this one end. We are done with our code, guys. Now let's run this and see what we get. And you can see we are getting a streaming response, very fantastic response that we got. We got LangChain is a platform designed to help. Let me make it a bit bigger so you can also read it. Make it 150. Now this is what we got. We got LangChain is a platform designed to help with testing LLM applications. It provides several features to facilitate testing, blah blah blah. Creating and managing datasets, bulk uploading, running custom evaluations, comparison views. So we got the output, and you can understand we have completely relied on NVIDIA NIM over here. Okay, so this is how you can bring up a Mistral model, load it, do everything with HyDE, whatever else you want to do that, and this is how you can do it with the open source model. You need, of course, infra to do that. You need Docker installed. So you need two things. You need probably a GPU, of course, and then you need a Docker installed in your machine to do this. But this is how you can do it. Okay. Now, this will be available. This will be available. The links will be available. The ID, everything will be available on the GitHub repository and also in the video description. If you have any questions, guys, let me know your question, thoughts, feedbacks in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content I'm creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. That motivates me to create more such Gen AI based content. Uh, that's all for this video, guys. Thank you so much for watching. See you in the next one.